Let's review different types of structured data, data primitives in R, and data primitives in Python. We need to know basic types of structured data. So we have continuous data that can take any value in interval, and as far as synonyms, you can see interval, float, numeric. You have discrete data that can take only integer value, such as count, for instance, and one of the synonyms is count. Categorical data, we can take only a specific set of values, categories. However, there's a large number of synonyms. We have factors, nominal, polycotonomous, etc. And binary is just a special case of categorical data with just two categories, values. Under synonym, we can find dichotomous, logical, Boolean. And we have ordinal data, which has explicit ordering. Categorical data with an explicit ordering. Thus, we have two basic types of structured data. Numeric data with two subcategories, continuous and discrete. Make sure you understand the difference between those two, as continuous represent time, duration, examples, and discrete we have counts, occurrences of events. Categorical data actually has three subcategories, or two subcategories, and one main category is just a fixed set of values. So the first subcategory is a binary data, which is a special case that takes only one of two values. It can be 0, 1, yes, no, or true or false. Ordinal data is another type, subtype of categorical data, where categories are ordered. So the question to you would be, why do we bother with the taxonomy of data types? So the answer is very simple. We need to determine type of visualization, data analysis, or statistical model, which will be based on different types of our data. The second question to you is, why do we need categorical and ordinal data, which is a subset of categorical? One of the answers is ordinal data preserves this user-specified ordering in charts, tables, and models. And we can also use it in terms of storage and indexing, which can be optimized in this case. So the key idea to take from types, different types of data, is that data is classified in software by type, and while we using software, we need to use it as a signal on how to process our data. Let's look at data primitives, in both in R and Python, which I hope you will be doing more often, and you will be very versed in both languages. So on the left, we have R primitives, and on the right, we have Python primitives. So the name, the first basic type for both, is integer in Python and R. To determine what class or type is, in R we would use class function, and in Python we would use type function. And if you look at definition, so integer will be in R, and int in Python. And finally, to convert something to integer, we would use as integer function in R and int in Python. So our next primitive is double or float. So if you notice in R, we would use, for example, value of 2.0 or 2 here, because we do not specify L. So if you if you assign value to a variable X and check the class, it will always be numeric. Float in Python, in the contrary, so we need to specify 0.0. For example, here, that to show that it's decimal, it's a float. We check our type, and the class is float. And to convert something to float, we would use float function. In R, we would use as numeric function. Finally, we have character or string. The use of double quotes or single quotes is irrelevant, so you can choose any of the types. Then when we check class or type, we would have character in R and str string in Python. And finally, to convert something to character or string, we would use as character function in R and str string function in Python. Additional resources also available to you if you wish to review R data types or Python data type.